The atmosphere. The atmosphere is the thin layer of air around the Earth, and it's composed of gases and small particles of water. The gases around the Earth are held in place by the force of gravity. Look at the figure. The atmosphere is a mixture of gases. Nitrogen and oxygen are the ones that contribute the most. There are also argon, carbon dioxide, and aerosols, particles such as dust, pollen, ash, smoke. These gases are super important to life on Earth because plants and animals depend on them to live. In addition to ensuring the gases necessary to maintain life on the planet, the Earth's atmosphere is responsible for a number of functions that protect the Earth's surface, such as maintaining the average temperature, defense against meteorite attack, and blocking ultraviolet rays. Look at this figure. Atmospheric pressure. Air molecules colliding with a surface cause atmospheric pressure. All these fast collisions add up to produce a large force on an object. Atmospheric pressure decreases as the height of a surface above ground level increases. This is because as the altitude increases, the atmosphere becomes less dense. So, the number of air molecules decreases. The weight of the air decreases. There is less air above a surface. Surface air pressure is weight of air in column above unit area. The Earth's atmosphere exerts a force on everything within it. This force, divided by the area over which it acts, is the atmospheric pressure. The atmospheric pressure at sea level has an average value of 1.01 times 10 to the power 5 pascals. This is commonly referred to as 1 atmosphere, which is equivalent to placing a 1 kilogram mass, 10 newtons weight, on an area of 1 centimeter square, or 10 tons on an area of 1 meter squared. Why doesn't all that pressure squash us? Remember that you have air inside your body too. That air balances out the pressure outside, so you stay nice and firm and not squishy. The natural pressure within our body is also about 1 atmosphere. As such, the internal pressure of our bodies is able to balance out the atmospheric pressure that acts on us. If this natural pressure was not present within our bodies, we would be crushed to death by the atmosphere. Example. The diagram shows how atmospheric pressure varies with altitude. Explain why atmospheric pressure decreases with increasing altitude. At increasing altitude, fewer molecules above a surface, so there will be less weight of air than below the surface. The figure below shows the cross-section of one type of aircraft window. The aircraft window has an area of 810 centimeters squared. When flying, the pressure inside the cabin of an aircraft is kept at 70 kilos Pascal. Use data from the diagram to calculate the resultant force acting on an aircraft window when the aircraft is flying at an altitude of 12 kilometers. Look at the figure. At an altitude of 12 kilometers, we have 20 kilopascal of atmospheric pressure. The air pressure acting from inside to outside is bigger than air pressure acting from outside to inside. The resultant air pressure is 50 kilopascals. Converting centimeters squared to meters squared and applying the formula for pressure, we have the force. Acting on window. Another example. One of the most effective ways of moving pieces of glass is to pick them up using large suction pads. The idea is simple. You remove the air from inside the pad and the atmospheric pressure pushes the pad firmly in place against the glass. Pressure is force over area. Atmospheric pressure is 100,000 pascals. The area of each cup is 0.0785 meters squared. Weight of glass should be balanced with the forces. So the weight of the largest piece of glass that can be lifted is 157 kilograms approximately.